characteristic of the compound is that the property of the compound, the entirely property of the compound is different from those of those of the constituent elements of the compound. So here let us take an example. Suppose here hydrogen. Hydrogen, what do we know? Hydrogen is a combustible gas. It is combustible. Hydrogen is combustible. Okay, I just want to tell you, no chatting among yourself. Okay, I can see some of you are chatting among yourself. You no need to chat among yourself. Don't write the comments like this. Just pay attention to the class. Okay, if you don't understand, if you don't know anything, that you can write in the comment box, or just listen. Okay, listen and try to understand. All right, good. Okay, so let us see the properties of the compound. Okay, are entirely different from those of constituent element. Now here we see hydrogen is a combustible gas. All right, we know. And oxygen, what is oxygen? Oxygen is a supporter of combustion. Oxygen is a supporter of combustion. But when hydrogen and oxygen combine together and they form water, what do we see about water? The property of water is completely different from hydrogen and oxygen. All right, so the property of water is completely different from hydrogen and oxygen. Hydrogen is combustible, water is not combustible. Oxygen is supporter of combustion, water is not supporter of combustion. All right, so here this also proves, this is the second characteristic of the compound, is that the property of compounds are entirely different from those of constituent elements. All right, so here we can see, okay, that hydrogen is combustible. After combining with oxygen, water is a compound which is not a combustible. Oxygen is a supporter of combustion. After combining with hydrogen, water is formed compound which is not a supporter of combustion. All right, let us go to the next characteristic. The next characteristic of compound is elements combined in a fixed proportion of atoms to form a compound. They have fixed proportion of atoms. Okay, they have fixed proportions of atoms to form a compound. All right, so this is the another characteristic of the element. Another characteristic of compound is they have fixed proportion of atoms to form a compound. Okay, so elements combined in a compound in a fixed proportion of atoms. Okay, which already I had shown you in my previous video. Again, I'm just teaching you, revising, so that you can understand and you can know better. So here if you see water, again I am taking the example of water. Okay, we'll take example of water and H2SO4. This is also a compound. Now, so the water here, water, how many hydrogen atom is? Hydrogen to oxygen, the number of atom is 2:1. Okay, this is fixed. Okay, over here hydrogen, oxygen, hydrogen, sulfur and oxygen, the combining atoms ratio is 2:1:4. Okay, so what do we understand? The third characteristic of compound is that the elements combine in fixed proportion of atoms to form a compound. Okay, the combining atoms, they have the fixed proportion of atoms, okay, to form a compound. So here we can see, take any example of any compound, you will notice and you will see that the combining atoms are always in fixed proportion, okay, or you can say they are always in a fixed ratio. Is that clear? Okay, let us learn the fourth characteristic of compound. The fourth characteristic of compound, a compound contains the constituent element in fixed proportion of mass. Okay, what we see, fixed proportion of mass. The combining elements in a compound, they have a fixed proportion of mass. Okay, again I will give you the example of water. Okay, by mass or by weight in water, okay, by mass by weight in water, what do we see? We see that the by weight 1:2, so we can say 2 part of hydrogen combines with 16 part of oxygen. So we can write in the simple ratio, we can say 1:8. 1:8. So what is the simplest form of the ratio of the combined mass of the combining atom? That is 1 part of hydrogen combines with 8 part of oxygen to form water. Or you understand in this way, suppose in 9 gram of H2O, that means water, in 9 gram of H2O, 1 gram is hydrogen and 8 gram is oxygen. Okay, this is very simple. Wherever you go, okay, you analyze the composition of the water, okay, you will find that the ratio or the proportion of the hydrogen and oxygen in water, okay, by their mass, okay, or by their weight is always 1:8. Okay, simple, in the simple language, how can we understand that? If we take one molecule of water, then one molecule of water, the simplest ratio is 1:8. We understand that means 9 gram of water has 1 gram of hydrogen. Let me write the hydrogen molecule, no problem. 1 gram of hydrogen and 8 grams of oxygen. But if I take 18 grams of water, then what? If we take 18 grams of water, then 2 gram of hydrogen and 16 gram of oxygen. Okay, 2 gram of hydrogen and 16 gram of oxygen. All right, so this is very simple. This is the fourth characteristic of a compound, that the combining elements, they have the fixed proportion of mass. Okay, mass of the combining atoms, of the combining elements. All right. So that is, these are the four characteristics of the compound which I just wanted you to know. I hope it has gone to your head, not above the head. Okay. So here, then I go to the next part of the chapter is, okay, next part of the chapter is, which already I had told you that I will be taking, or I will be teaching you, that is the type of mixtures and the different methods to separate the constituent or the component of the mixtures. Okay, so here we go. So I hope you all are keeping fine. So the next part is the mixture. Okay, now we will learn the type of the mixtures, which you already know that the different type of the mixture. There are mixtures are only basically two, the homogeneous and the heterogeneous. But on the basis of the state, its component, we will have the different type of mixtures. So I'm just following one chart, so the chart will help you. Okay, so here we will write, see, solid. First mixture we will see the solid solid. Okay, the first type of the mixture is the solid solid. All right, so we'll take the example of homogeneous, and then we'll take the example of heterogeneous. Okay, we take the example of homogeneous and we take the example of heterogeneous. Okay, somebody is writing to explain or repeat the proper characteristic of the compound once again. So this is for you to understand the characteristics of the compound. Important characteristics: the compound can be split into its constituent only by a chemical process or chemical means. I gave the example of the electrolysis of water. Electrolysis of the water is a chemical process where water can be split into hydrogen and oxygen. Along with this, we have some other example where water can be separated from its compound, hydrogen can be separate from its compound water when we use active elements, sodium, okay, potassium, calcium, magnesium, when they react with water and they form hydrogen gas and their respective hydroxides. Then I said the second characteristic, the property of the compound is entirely different from its constituent elements. Okay, take example of water. Now the water is a water is not a combustible as not a supporter of the combustion, but hydrogen, we see hydrogen is a combustible gas and oxygen is a supporter of the combustion. So their properties are different. Third, I said the elements combine in a fixed proportion of the atoms. So if you take water H2O, that means there is a two atom of hydrogen and one atom of oxygen. If you take CO2, that means one atom of carbon and there are two atoms of oxygen. Then fourth, I said the combining elements, they combine, okay, in a fixed proportion of the mass, okay, which I said if 1 gram of hydrogen combines with 8 grams of oxygen, then they form a 9 gram of water as a compound. So these four are the important characteristics. Now let us see the mixtures. Mixture, I have made a chart like that. I will write one by one, solid plus solid, and then we categorize homogeneous and the heterogeneous. So first we see the solid plus solid. The mixture type, the first type, when two solids are mixed together. Okay, so First, you will see the solid and solid. Example, we can have it, all the alloys. All alloys. You know the alloys? Huh? Yes, you have learned this in your previous class. Alloy is the homogeneous mixture of hmm, two or more metals or metals and non-metals. The example that we can say the bronze. The bronze is nothing, zinc, copper. Okay. Next, then the heterogeneous mixture. What it can be? Heterogeneous mixture simple: salt plus sand. Salt plus sand. I am giving you one example so that you can understand. Okay, or you remember it. Then we have the next liquid. Liquid. Next example, next type of the mixture is liquid and liquid. So liquid in homogeneous. Okay, the homogeneous what we can see. Okay, homogeneous what we can see that you can have example like okay, alcohol plus water. Okay, alcohol plus water or some beverage in the water. This is also the example of homogeneous. And heterogeneous part, what we will take? Heterogeneous part, what example we will take? Heterogeneous part, we will take oil plus water. Okay, then next we will see gas mixture. So homogeneous gas mixture is what? Air. Air is the best example, where it is the example of the homogeneous mixture of gas and gas, and we do not have much we do not have about the heterogeneous. Okay, then we will see the solid plus liquid mixtures. Then we see the solid plus liquid mixtures. The homogeneous, we can say the salt water or salt solution, sugar solution. Okay, and heterogeneous, we can have the sand plus water or chalk plus water. These are the example of heterogeneous. Okay, next we will have solid gas mixture. Solid gas mixtures. Solid gas mixture, there is nothing much, nothing. We have the homogeneous. Homogeneous, nothing is like that. Solid and gas, they do not mix completely or distribute equally to form the homogeneous. They form the heterogeneous. That is what the smoke. Okay, smoke that we see which comes out from the chimney. This is the example of a heterogeneous solid gas mixtures. Then we have the liquid gas mixture. Liquid plus gas mixtures. Liquid plus gas mixtures, in very simple, we drink soft drink. Okay, we enjoy now the summertime, we would like to take some cold drinks. Okay, like soft drink, like some irritated water. Okay, so those are the example of the homogeneous mixture of liquid and gas. So I'm writing that soft drinks. Soft drink is one of the example of homogeneous, and the mixture and heterogeneous mixture. The example of liquid gas is mist, that we see mist outside when temperature falls. This is an example of heterogeneous mixture of liquid gas. All right, fine. So here these are the examples of the mixtures. Okay, and I have divided them into the different category, that is the solid mixture. Homogeneous is all the alloys. All the alloys are the example of the homogeneous mixture. Okay, now somebody is asking which gas is there in a soft drink. Is it Okay, which gas is there in soft drink? That is, we in soft drink liquid gas mixture is homogeneous is the soft drink. Okay, now here we use the carbon dioxide gas. Now carbon dioxide gas in the presence of 80 atmospheric pressure. In presence of 80 atmospheric pressure, it dissolves in a water. Okay, it dissolves in a water. Under some pressure, carbon dioxide gases dissolve in water and makes the water irritate water. Irritate water, that is, when we open it, the fizz of carbon dioxide, the bubbles of the carbon dioxide comes out. So with that solution or that uh, irritated water, we put some beverage, some flavor like orange or some cola and this, and then we make the soft drinks, or we make a cool drink that we use in a when we feel thirsty in summertime. Okay, if you have some other question, then you can ask me. Okay, somebody is asking whether you have to write all this in your copy or not. So you wait for my class to get end. Okay, so but I will send some of the homeworks what you need to write in your chemistry copy for this chapter. Okay, I will send it in the dojo class. So uh, you will write the answers of the question which I will upload it. Okay, and anyhow, whatever I have taught from beginning till now, okay, you can write those topic or those points in your copy for your understanding, so that you will not forget it. Again, so once again, I'm just giving you a little summary from the beginning, which what I taught. We started the chapter with the elements, compounds, and the mixture. I I taught you the property of the elements and the different uh, characteristics of the elements, and elements how it is represented by the. It is represented with the help of symbol. All right. And then I taught you the characteristics of compound just now. Okay, the four characteristics of the compounds, and then characteristics of the mixture is just opposite of the characteristics of the compound. You can learn it through it. Okay, then here the different type of mixtures and some examples. Okay, you please learn this part, and when I will come for my next class, okay, I will teach you the different methods, and explain the different methods to separate the constituent or the component of the compound, sorry, mixtures. Okay, and a different type of mixture, what are the methods we need to separate those. Okay, somebody asked me how the mist is formed. The mist is the example of the liquid gas mixture. Okay, it is the heterogeneous. Okay, it is heterogeneous. All right, now heterogeneous mixture, where the gas and the water are not mixed together. Right, mist is what, when the temperature falls. Okay, sometime you see on the car's glass, or on the window pan, when temperature, you see some water vapor mixed with the gas, some mist like fog. You can understand in the simple language is the fog. Okay, where you cannot see where the person is standing. Okay, so this is the example of the mist. Yes, you can use the rule copy for your chemistry. uh, I hope that you started writing, because previous class was taken by Miss Uma, and she had given many work to be written in your chemistry copy. I hope you have written, so you can continue my work in the same copy. All right. So once again, what I taught you today, just revision. Okay, I taught the important characteristics of the compound. A compound can be split into its constituent only by the uh, only by chemical means. Okay, like electrolysis and decomposition of the water by using the active elements. These are the example of the first characteristics that compounds can be split into its constituent by the chemical means. Second characteristic, I said the property of the compound is entirely different from its constituent elements. Already I gave you the example that oxygen is supporter of combustion and hydrogen is combustible gas itself, but when they combine together they form water, which is neither supporter nor combustible. Then I said the third property that elements combine in fixed proportion of the atoms. All right. So this is also very simple. And the fourth was that the elements combine in a fixed proportion of their mass. Okay. So as you have received my message that my next class will be on Thursday, sharp at 9 o'clock, and I request all of you, those who have not yet subscribed my channel, so you can subscribe it, okay, so that any information, any live class will be notified to you. Okay, you will have the notification for my next class. Yes, next class is on Thursday. Okay, and next class I will teach you the different methods of different methods to separate the component of the mixtures. Okay, and each method I will try my best to explain in detail so that you will understand. Okay, still some of you are confused with your interleaf copy or rule copy. You can use the rule copy if you have, because you have already started writing, I suppose. Okay, so all the best. Thank you once again for attending my class. I hope you find interesting. And okay, some is Tarun Kumar is asking what is the main difference between the compound and the pure substance. Now see, this is compound is the part of the pure substance. Okay, there is no much difference. Compound is the part of the pure substance. Okay, all right, fine. So all the best, and I hope you are keeping safe at home. Be good, be safe, and God bless you all. So see you in the next class.